Hello and welcome back to the lecture on applied econometrics, and we have been talking about the difference in the concept of correlation and causality. And this is a continuation of the previous lecture, and we are talking about the difference in what and why, and how that is actually related to the concept of correlation and causality. So we have basically seen a series of what questions are actually leading to a why questions, and there is a hierarchy of these what questions. So you keep on uncovering the whats. It's like how you peel the onion, right? So there are multiple shells that you keep on uncovering. So one what leads to another what, and that what leads to another what, and so forth. So the more the deep you go, the more sort of clarity you get, so far as clarity is concerned. Okay. Now we will try to understand the structure, as in how we really go to the process of discovering causality, how we actually know the fact. Okay. So let me actually try to represent it diagrammatically, give you some ideas how to actually do this uncovering. Okay. So let's say A is causing B. Okay. So let's say that's an idea, that's a hypothesis. We really don't know if A is causing B, but we have some idea that perhaps A is causing B. Now how do we know for a fact that A is causing B? Okay. So there could be, like we can see that, when B is happening, A is present, or when A is present, B is happening. One example could be smoking cigarette and, getting cancer. Okay. So if people are smoking cigarette, people are also getting cancer, or people who are getting cancer, if you sort of do a diagnosis, you will see that they are smoking cigarette, but it's not always the case, but we'll come to that. But let's say that is what we try to understand if, for a fact, if smoking cigarette is causing cancer. Now, how do we really come to the causal part? How do we really come to establish that this is actually happening? So just the two factors are happening together, just that two factors are varying together, does it ensure causality? Now I will give you some scenarios. So one could be, let's say, there are so many other factors. Let's say there is a factor X, there is a factor Y, and there is also our A, and there is a factor Z, and all of these, let's say, they actually causes B. Okay. There could be some other possibility. So basically cancer can be caused by some other factors, including A. Now let's say there is another possibility that, all right, so A is actually causing some U, and U is causing B, whereas your X, Y, Z can also cause B, right? There could be another possibility. Let's say there is a factor which is, let's say, V is causing A and V is causing B, and there are X, Y, Z which also cause B. Okay. Now pause for a moment and see the structures that I have just drawn. So in the first case, there are many factors which are causing B, including the factor A. In the second case, A is responsible for B, but not directly, via U. So A is causing U, U is causing B. Okay. In the third case, V is causing, so there is a factor called V, and V is causing A, whereas V is also causing B. So because of the presence of V, both A and B are created. Okay. And there are other factors like X, Y, Z which can also cause B. So it is very important for us to actually understand the role of A in causing B. Okay. There could be another scenario, let's say, where your A and B are just co-varying, just randomly, just basically by chance. You have no idea if they are actually related or not, but for whatever reason they are actually varying together. It's just, let's say, it's an accident. Okay, some accidentally, all the observations you got, you found that both A and B are varying together. Now how do we really ascertain the causal link? This is our question. How do I really know if A is for a fact causing B? Okay. Now let me actually let's try to see how how do we further conceptualize the problem. So let's say this is our solution space, and there are many possibilities, many factors just I have drawn. Let's say A is 1 and there are X, Y, Z, U, V, and all of these, whenever we see their presence, we also see the presence of B. Okay. So that is kind of the problem statement. Now let's say A is actually causing B. Now let's say cigarette smoking actually causes cancer. but not all cigarette smokers are actually having cancer. So, that is another problem. So, A can cause B, or for some people A is not causing B. Okay. So, that is basically an understanding which we have to use the we have to understand probabilistically, okay, whether there is a probability that A can cause B, and what is the probability and when you can actually say the causal part is involved, but we will come to that later, the probabilistic part. But just to understand whether something is actually causing A, whether something is causing something else, like whether A is causing B. So, we have to have some process, we have to have some path delineated for us to actually uncover the whole process. So, let us say one way to do that is to repetition. So, one was to see the repetition. So, let us say the previous example of cancer and cigarette smoking. Let us say I have seen, let us say some researcher is interested in this question, and let us say he has taken data from say UK population survey, okay, and they have this data on people having people who are addicted to cigarette and who got the cancer, and they have, the researcher group has actually seen that people who are addicted to cigarette are also likely to have cancer. But does that assert in the fact that cigarette smoking is causing cancer? So, you need to actually see whether that fact is true in other contexts as well. So, perhaps the researcher group will say, all right, so there was some reason this particular cohort we see this kind of results, but perhaps we need to see more. So, what they will do, they will go back to UK population survey for past 100 years, let us say. And in past 100 years, let us say they have this data on people having cigarettes, smoking cigarettes and getting cancer, and they actually see that it is indeed true that people who are actually smoking, they are actually getting cancer, and that is true not just for this cohort, but all the cohorts they have seen for the past 100 years. All right. So, then the question will come that could there be something in the genes of people living in UK that actually is causing cancer, like that is a particular variant of gene they have, and that is just causing cancer, and the fact that cigarette smoking causes cancer may not be true if they go to Asia or say United States or some other continents. Okay. So, then the researcher group is further sort of they will expand their research, they will go to Australia, they will take data from Australia, they will take data from Asia, they will take data from United States, and they will see that actually for all these continents it is actually the people who are smoking cigarette that actually causes cancer. Okay. So, even now that the correlation between cigarette smoking and cancer has become a little more prominent, because we can see the relationship across different contexts. So, we are basically confirming our belief about this correlation. We are yet to reach to the causality. We are still talking about correlation, but we are confirming our belief about this correlation. All right. Now, whether this repetition of certain thing actually helps you to prove causality? Perhaps not. And here I'll give you an example. So, the previous example was cigarette smoking, cancer, and it was for say UK and other continents for a long time horizon. Okay. And all I am saying here is that if that is the case, then it is only going to confirm my belief that cigarette smoking is causing cancer. It is still not proving, and why it is not proving, and I will come to that. So, this is another story, okay, and the story is about a philosopher, Bertrand Russell. You might have heard of Bertrand Russell. So, there is a term called Russell's chicken. Now, what is Russell's chicken? So, it is the story of a chicken, okay. The chicken is living in its owner's home, and the owner actually feeds the chicken pretty nicely. So, every day in the morning it gets its breakfast and other meals the chicken gets, and chicken it gets a sort of very good treatment. So, it is like it becomes a routine for the chicken to get that meals in time, right. Now, so the chicken would believe that perhaps this will continue, the meal will come in the given time till the date it was actually slaughtered. Okay. So, the chicken it was getting the meals in right time, and then one day it got slaughtered. So then the question will come, why the owner has actually, the chicken might ask why the owner has actually stopped the meal, and it can only ask when it is dead already, right? So it's actually a very tricky question, because that actually talks about the question on hypothesis, like which one is true, which one for a fact is true. It can be sort of called true unless proven otherwise. So the chicken can think that the food will come as per the schedule unless it was proven that it is not. Okay. And this is something you can also, you might have also heard of, Karl Popper, who talks about the theory of black swan. So all the swans are white till the time you see a black swan, right? So you really do not know what is causing what. Okay. So here the example, to illustrate it further, I will say that, let's say in the previous example where the owner was feeding the chicken, the owner was at the same time, let's say, was feeding its dog, or let's say it was also feeding its pigeon. Okay. Now the owner actually ended up killing the chicken. Okay. So it was feeding, and then it killed the chicken, whereas it did not kill, the owner did not kill the dog or pigeon. Now why the dog and pigeon was not killed and why the chicken was killed? So till the time all the animals were getting regular feed, so that means perhaps the owner is doing out of love, okay, out of love for the chicken, and out of love for the dog, and out of love for the pigeon. But when the owner actually end up killing the chicken, so it was perhaps, the causal link, the why owner is feeding the chicken is perhaps, proven that the owner is not feeding the chicken because it loved the chicken, but rather the owner actually wanted to eat the chicken after whatever time. So now we can further ask that, why owner actually did not love chicken, whereas the owner actually loved the dog or the pigeon. So you have to go to that human brain, like why perhaps certain behavior of the dog or the pigeon actually, the owner actually sort of wanted that their company, and the owner might have liked the dog or the pigeon, but for when it came to chicken, it was not that sort of that chemistry, that brain chemistry that actually happened. So owner actually wanted to eat the chicken. It might also be because of the historical learning of the owner. So you have to go much deeper into neuroscience to understand the reason why owner loved the chicken, why owner loved the dog and pigeon and did not kill, and on the other side it did not love the chicken and killed. Okay. So that's basically how you go to understand the layers of what questions. Okay. So what owner did, and then you ask why, and the moment you ask why, you again ask, so what exactly is the brain chemistry that happened for the owner so that it killed chicken but not the dog or not the pigeon. Okay. So that is how we will try to understand these layers of questions. Now so that's basically how we sort of uncover the causality. So it's just a continuation of the previous lecture, and in the next lecture we will further see why it is so important for us to have an understanding of causality, and what is the role of econometrics, which we are trying to learn in uncovering the causality. Okay, that's the scientific part of it. So with that we will actually conclude the lecture on causality. Thank you.